Welcome back in lecture series on topic chemical thermodynamics. In last video we have studied first law of thermodynamics and different statements of thermodynamics and formulation of first law of thermodynamics. And today we will study the mathematical expression of first law of thermodynamics for different types of thermodynamic processes such as isothermal process, adiabatic process, or isochoric process, isobaric process. For all these types of process, we will study the mathematical expression of first law of thermodynamics. So let us see here. According to first law of thermodynamics, the mathematical expression of first law of thermodynamics is delta U is equal to Q plus W, where Q means heat supplied to the system and W means work done on the system, and delta U is the change in internal energy. So delta U is the increase in, as its sign is positive, it is an increase in the internal energy of the system. Q is the quantity of heat supply, as its sign is positive, and the W, its sign is also positive, so it is amount of work done on the system. So this is mathematical expression for first law of thermodynamics. Now we will apply this for different types of processes. Now first, that is isothermal process. Iso means same, thermal means it is concerned with temperature. So a process in which temperature of the system remain constant throughout the transformation, that is called as a isothermal process. We have studied in detail isothermal process in previous videos on processes. So process in which temperature of the system remain constant, then that is called as a isothermal process, and therefore in isothermal process change in temperature, that is delta T, is equal to 0, and internal energy is a function of temperature, and therefore change in internal energy, that is delta U, is equal to 0, as internal energy depends upon temperature and temperature is constant. If there is no change in the temperature, internal energy is also not changed, it also remain constant. Now according to the equation of first law of thermodynamics, delta U is equal to Q plus W. But here delta U is equal to, that is change in internal energy is equal to 0. Now if you substitute this value in the equation of first law equation, then 0 is equal to Q plus W. Q means heat supplied, W means work done on the system, and therefore Q is equal to minus W. That means what? When heat is at constant temperature, when heat is supplied to the system, then this heat is utilized for the expansion of gas, that is system does work on the surrounding, or work is done by the system, and that is what? Expansion type of work, because there is this heat supplied is not utilized to increase or decrease the internal energy, because internal energy is constant. Change in internal energy is equal to 0. Temperature is also equal to 0 in isothermal process. Therefore, whatever amount of heat is supplied to the system, the entire heat is utilized for the expansion of the system. So that is the meaning. That means see here, suppose this is the system and here it is the initial state, gas is enclosed in this system cylinder, and it is fitted with a weightless frictionless piston, movable piston, and suppose this is the V1 is the volume at the initial stage. But when you supply heat to this system, then what happens? the expansion of gas takes place. If you keep the temperature constant, then whatever amount of heat supply that is utilized for expansion of the gas, that is system. So Q is equal to minus W. This negative sign indicates what? Expansion takes place. Or you may write like this also, minus Q is equal to W plus W. Now you have studied sign convention, so plus W means, so when sign of work done is positive, then it is which type of work? Compression type of work. And if compression takes place, then heat is released by the system. So here heat in isothermal process, heat absorbed by the system is entirely used, completely used for doing the work on the surrounding, and therefore Q is equal to minus W. This is what? Mathematical expression of first law of thermodynamics for isothermal process. Or this what? Minus Q is equal to W, that is compression. See here, if you increase, suppose this is the initial state, gas is enclosed in this cylinder, temperature of the system is constant, and if you increase here, this is what? The initial volume of the system. Now if surrounding does work on the system, surrounding does work on the system, then what happens? The heat is released by the system. Heat is released by the system. Compression takes place and heat is released by the system. So minus Q is equal to W. That means if compression type of work is there, then heat is decreased. That is, my heat is released. So if or when work is done on the system by the surrounding, it results in release of heat, and therefore W is equal to minus Q at constant temperature. That is, for isothermal process, when work is done on the system by the surrounding, then W is equal to minus Q. So that is mathematical expression of first law of thermodynamics for isothermal process. What is it? Q is equal to minus W, or minus Q is equal to W. When Q is equal to minus W, expansion of work, expansion type of work takes place. And when W is equal to minus Q, compression type of work takes place and heat is released by the system, and therefore sign of Q is negative. See here, the second process, that is adiabatic process. Adiabatic process means a process in which there is no exchange of heat between system and surrounding. That means a process is carried out in an insulated vessel or in a thermos flask, where there is no exchange of heat as well as matter with the surrounding, and therefore in such a cases Q, that is heat, is equal to 0. Heat of the system is equal to 0. No change in the heat. Now according to first law of thermodynamics, delta U is equal to Q plus W. But here in adiabatic process, change in heat, that is Q, is equal to 0, and therefore if you substitute this value of Q in first law of thermodynamics, equation of first law of thermodynamics, then W, this delta U, that is increase in the internal, sign is positive, so increase in the internal energy is equal to 0 plus W, because heat exchange in adiabatic process, heat exchange is 0. There is no exchange of heat, therefore Q is equal to 0, and therefore increase in the internal energy is equal to 0 plus W. That means what? Delta U, that is increase in the internal energy is equal to W. That means increase in internal energy is utilized to do the work on the system. Or alternate statement of this, you can state like this also: when expansion type of work takes place in adiabatic process, then internal energy of the system decreases. Or here, when compression type of work takes place in adiabatic process, then internal energy of the system increases. That means what? Temperature of the system increases, as internal energy is a function of temperature. Here also what? The delta minus delta U is there. Therefore, whenever expansion takes place in adiabatic process, then the decrease in the temperature takes place. That means cooling takes place. When expansion takes place in adiabatic process, change in internal energy decreases. That means temperature also decreases, because internal energy depends upon temperature. So temperature also decreases. So here an increase in internal energy, that is plus delta U of the system, is the work done on it. That is delta U is equal to W. So whenever work is done on the system, then internal energy of the system increases. And similarly, here alternate statement, that is the minus delta U is equal to minus W. That means if the work is done by the system on the surrounding, work is done by the system, that means expansion, at the expense of internal energy, the internal energy of the system decreases. So for expansion, the internal energy is utilized. Internal energy decreases and system does work on the surrounding, or expansion type of work takes place. So here the delta U minus delta U is equal to minus W. So example of this adiabatic expansion is cooling effect of gas in refrigerator. That is an example of adiabatic expansion. What happens when the door of refrigerator is closed? Then the gas inside the compressor expand, and that means expansion takes place. That means work is done by the system, and therefore what happens? Internal energy of the system decreases. That means temperature of the system decreases, and therefore it produces a cooling effect. So whenever the door of the refrigerator is closed, then what happens? Expansion of gas inside the compressor takes place and cooling effect is observed. Then third one, that is isochoric process. Isochoric process means it is a process in which volume of the system remain constant during the transformation. That means what? Any change, if it is carried out in a closed vessel or in a sealed vessel, then that process is called as what? Isochoric process. And in isochoric process, change in volume is equal to 0. Delta V is equal to 0. And therefore, equation of first law of thermodynamics is delta U is equal to Q plus W. Therefore, here delta V is equal for isochoric process, delta V is equal to 0. So if you substitute this value in above equation, that is Q is delta U is equal to Q plus W, we will get what? Q plus W. Now here you know that W is equal to work done is equal to minus P external into delta V. But delta V is equal to 0. Delta V is equal to 0, and therefore this whole quantity, that is external pressure into change in volume, it becomes whole quantity becomes equal to 0, and therefore here delta U is equal to QV. Here V subscript is used because the heat is supplied at constant volume. So increase in internal energy is equal to heat supplied at constant volume. As delta V is 0, work done is equal to 0 in case of isochoric process. So delta V is equal to QV. That means whatever heat supplied at constant volume, it is only utilized to increase the internal energy of the system. That means temperature of the system, as internal energy increases, temperature of the system also increases. So delta U, that is increase in internal energy, is equal to QV, or minus delta U, that is decrease in internal energy, is equal to release of heat, that is minus QV. So delta U is equal to QV, or minus delta U is equal to minus QV. This is for isochoric process, where QV means what? The QV means heat supplied to the system at constant volume, or minus QV means heat release from the system at constant volume. So for isochoric process, a change in internal energy of the system is due to heat transfer at constant volume. And as internal energy is a state function, QV is also a state function, because delta U is equal to QV. Delta U is a state function. Change in internal energy is a state function, or internal energy is a state function, and therefore heat supplied at constant volume or heat absorbed at constant volume is a state function. Remember that this point is very important. That is actually the Q, that is heat and work, are path function. But here if this heat is supplied or released at constant volume, then it is a state function. Otherwise heat is the state path function. We have studied in my previous video about path function and state function. Now the fourth one, that is isobaric process. Isobaric process means those processes which are carried out at constant pressure. So it is a process in which pressure of the system remain constant during the transformation. That is called as a isobaric process. That means in isobaric process, change in pressure is equal to 0. There is no change in the pressure. Pressure remain constant. But pressure remain constant, but volume changes. So equation of first law of thermodynamics is what? Delta U is equal to Q plus W. But here therefore delta P is equal to 0 for isobaric process. But delta V is not equal to 0, and therefore if you substitute this value in first law of thermodynamics, then what we will get? See here. You know that W is equal to minus P external into delta V, and therefore delta U, that is increase in the internal energy, is equal to Q, that is heat supply to the system, plus work done on the system or work done by the system, minus P external into W. Therefore here delta U is equal to QP. Here heat supplied is at constant pressure. Therefore like QV, here we will replace QP by Q by QP. That is heat supplied at constant pressure, plus minus P external into delta V, and that is equal to what? Delta U is equal to QP. QP means heat supplied minus P external into delta V, that is work done on the system. So here that is equal to what? Qp. Therefore Qp is equal to delta U plus P delta V. That means Qp, that is heat supplied at constant pressure, is utilized to increase the internal energy as well as to do the work, that is work done on the system or work done by the system. So plus W, that is P external into delta V. So Qp is equal to what? Delta U, that is increase in internal energy plus work done either by the system or on the system. And therefore here Qp is equal, delta U is equal to Qp minus P external into delta V, and this Qp is equal to delta U plus P external into delta V, where Qp means heat supplied at constant pressure. So heat changes taking place at constant pressure, these are generally indicated by symbol delta H. Delta H means enthalpy change, and therefore delta H is equal to Qp, that is heat supplied at constant pressure. Delta H is equal to Qp, that is heat supplied at constant pressure, and that is equal to delta H is equal to delta U plus P external into delta V, where delta V means change in volume, P external means pressure, and P external into delta V means what? Work done. So change in enthalpy is equal to delta U plus P external into delta V, that is equal to W. So delta H is equal to delta U plus W. So this is what about the mathematical expression of first law of thermodynamics for the different types of processes. Thank you.